Topic: Precision Farming Systems, GPS, Mechanization. At the end of this lesson you should be able to understand the following concepts: precision farming, GPS, mechanization in agriculture. Learning content covered in grade 12 terms 2 and 3. Construction processes, tools and equipment. Concepts and skills. Precision farming. https://youtube.be/yfzhfxhts. What is precision agriculture? Precision agriculture seeks to use new technologies GPS, GIS, VRT, robots, drones, yield maps and more modern technology to increase crop yield and profitability, while reducing traditional inputs, soil, water, fertilizer, herbicides, and insecticides, to crops. Let grow. In other words, farmers who use precision farming use less to produce more. GPS devices on tractors, for example, enable farmers to plant crops in more efficient patterns and move from point A to point B with more precision, saving time and fuel. Lands can be leveled with lasers, which means that water can be applied more efficiently and with less flow away to local streams and rivers. The result can. Precision farming offers economic and ecological improvements. Reduction of resources, seeds, fertilizers, pesticides, fuel. Reduction of machine and working hours. Improving crop yield and crop quality. Minimizing the environmental impact. Complete documentation of the production process. What is GPS? The Global Positioning System, GPS, is a satellite-based navigation system consisting of at least 24 satellites. GPS works 24 hours a day in any weather conditions, anywhere in the world, without subscription fees or setup fees. The U.S. Department of Defense, USDOD, originally launched the satellites into orbit for military use, but they were made available for civilian use in the 1980s. How GPS works? GPS satellites orbits the Earth twice a day in a precise orbit. Each satellite transmits unique signal and orbit parameters that allow GPS devices to decode and calculate the exact location of the satellite. GPS receivers use this information to calculate the user's exact location. In essence, the GPS receiver measures the distance to each satellite at the time it takes to receive a sent signal. With distance measurements from a few more satellites, the receiver can determine the position of the user and display it electronically. E.g., measure your running route, map a golf course, find a way home from anywhere. To calculate your 2D position, latitude and longitude, and orbital motion, a GPS receiver must be connected to the signal of at least 3 satellites. With 4 or more satellites in sight, the receiver can determine your 3D position, latitude, longitude and altitude. Generally, a GPS receiver will detect 8 or more satellites, but it depends on the time of day and where you are on Earth. Some devices can do it all off your wristwatch. Once your position is determined, the GPS unit can calculate other information, such as speed, direction, trajectory/bed, travel distance, distance to destination, sunrise and sunset time, and much more. How accurate is GPS? Today's GPS receivers are extremely accurate thanks to their parallel multi-channel design. Our receivers are quick to pick up satellites when they are turned on for the first time. They retain detection in dense tree cover or in urban environments with tall buildings. Certain atmospheric factors and common problems can affect the accuracy of GPS receivers. Garmin GPS receivers are usually within 10 meters accurate. Accuracy is even better on the water. Some Garmin GPS receivers' accuracy is improved by WAAS, Wide Area Augmentation System. This capability can improve the accuracy to better than 3 meters by giving corrections to the atmosphere. No additional equipment or fees are required to take advantage of WAAS satellites. Users can also get better accuracy with differential GPS, DGPS, which corrects GPS distances by an average of 1 to 3 meters. The U.S. Coast Guard operates the most common DGPS correction service, which consists of a network of towers that receive GPS signals and send a corrected signal through beacon transmitters. To get the corrected signal, in addition to their GPS, users must also have a differential beacon receiver and beacon antenna. Use of GPS in agriculture and farming. GPS use in agriculture. Self-propelled tractors, stretchers cannot manage them themselves. If farmers plow their fields with a GPS survey, the tractor can then be programmed to follow the same route for cultivation, fertilization, pest control, and harvesting. The programming of tractor routes has the potential to save a lot of money for the farmer. Pesticide sprayers, insects do not attack a land with a uniform distribution. Instead, the outbreaks of insect activity were concentrated in certain areas. Workers moving through the crops can use a GPS to record the location of insect problems. The data can then be used by crop spray pilots to selectively determine the problem areas instead of treating an entire field. This method saves time, fuel, insecticides, and crop exposure to chemicals. Tracking of livestock, the location of valuable animals on large farms can be monitored with GPS transmitters attached to a collar around the animal's neck. When animals are sent to the market, the GPS transmitters can be used to determine their location. Accurate planting, GPS can also be used conveniently when planning the planting of a specific crop. Each seed has a specific spacing and planting depth in different soil types to ensure maximum yield. Creation of yield cards, GPS plays an important role in creating yield maps for specific crops. During harvest, for example, GPS can be used to map expected yields of a given crop from one piece of land based on the land characteristics and the seed characteristics. Harvest, GPS plays an important role in determining the area of a farm that is ready to be harvested and how the harvest will take place. The GPS will also give an estimate of the size of the area being harvested and the expected yields from the area. Finding a yield map, GPS can also be used to track a yield map by mounting a GPS receiver on a farm machine and then collecting the data. Environmental control, application of herbicides or pesticides based on the capacity of each square meter reduces the application rate of the pesticide used. This allows the soil to absorb all the pesticides, which reduces the chance of runoff. Farm planning, GPS plays an important role in the planning of a field ready for planting. GPS will give the total size of the area and help to determine which crop will be planted on which part of the fields by using different factors such as soil properties and crop characteristics. Field mapping, GPS gives an accurate estimate of the field being prepared for farming. This will allow experts to tell which part of the field will be used for farming activities and which area will be used for other non-farming related activities. Taking soil samples, soil sampling is one of the most important uses of GPS in agriculture. It is important to know what type of soil is available on a given piece of agricultural land, as this will help determine the type of crop planted on the farm. Crop exploration, GPS provides an accurate mapping of an area that helps to search for crops grown in a specific area. In this way, experts can identify the nature and type of crops that thrive within a particular environment and help to improve the quality of the crop. Yield mapping, after a crop is planted and ready for harvest, GPS can be used to estimate the yield of a given agricultural land. This can be achieved by aerial mapping where experts can determine the amount of yields according to the area covered by the crop. Correlation of production techniques with crop yields, GPS can be used to form a correlation between the production technique used over a given piece of land and the crop yields after a given period. This information can then be used to determine the viability of a given technique. Mapping of soil properties, GPS plays an important role in determining the soil properties of a given soil to determine its variability and suitability for a given crop. It also helps researchers determine which area of an agricultural land contains what type of land and which area is suitable for a given crop. Location of machinery, it is easier to locate any farm machinery on a large piece of land thanks to GPS. The farmer does not have to physically go out and locate farming equipment, especially in cases where the number is high. GPS can determine the exact location of this farm machinery. Machine direction technology requires the use of autonomous machinery for farming. GPS is used to direct this machinery to decide in which direction the seeds will be placed and the spaces between each seed. Identification of suitable cultivation areas. GPS plays an important role in determining which areas in a given agricultural land are suitable for cultivation. This is done by mapping the area under cultivation and analyzing the soil samples to determine the viability of the soil. Classification of cultivation areas on the basis of different characteristics. GPS can be used to classify different areas based on different characteristics such as soil types and the site maps. Areas that are not suitable for cultivation can be identified and alienated, while areas that are suitable can be developed. Assessment for the availability of water in an area. GPS was used to assess the availability of water or water resources within a given location. Water sources such as rivers or canals can be easily singled out with GPS. Identification of irrigated crops. GPS can also be used to identify areas where crops have been irrigated and those that have not been irrigated. It helps to create a profile between irrigated crops and non-irrigated crops and to make comparisons. Identification of swamps and other waterlogged areas. GPS can be used to identify swampy areas and waterlogged areas that may not be ideal for certain types of crops. It helps to determine the suitability of these fields for certain crops and their unsuitability for other crops. Mapping of rivers. GPS helps in compiling a map of all rivers in an area that builds a profile of the area with respect to water flow. Farmers and researchers can see the presence of rivers and help determine the crops grown in that area. Land use in the area. GPS can also be used to monitor land use within a given area. Using GPS, it is easier to see which area of the soil has been cultivated and which part of the soil has been left bare. Contour mapping. In cases where the country is irregular, GPS has played an important role in determining the contours within the specific environment. This is because some crops may not do well in contour countries, while others may thrive in these countries. Mapping of irrigation systems, dams and canals. In cases where the land needs to be irrigated, GPS can help locate irrigation systems such as dams and canals. Meteorological mapping such as climate patterns. GPS plays an important role in mapping some climatic conditions that determine the type of crop that can grow in a given region. Staff mapping. GPS can also play an important role in mapping the number of staff members on a given agricultural land at a specific time of day. This is important if a farmer wants to measure the productivity of the staff on a farm. Planting maps. GPS can help in compiling a map of a plantation and determining the crop yields in a given plantation. Mapping of water resources. GPS can also be used to map existing water resources within a given area to determine the viability of crop growth and crop yields in a given area. Emerging agricultural technologies that will change the world. The following are advances identified with agricultural development. Sensors. Sensors help agriculture with the constant traceability and determination of yields in farm animals/crops and the condition of farm machines. Food. Food can directly benefit from hereditary adaptation and possibly from the delivery of meat specifically in a laboratory. Automation. Automation helps agriculture to deploy automated and micro-robots to monitor and provide feedback at high levels. Engineering. Engineering includes advances that expand the scope of farming to new resources, new places, and new areas of the economy. Sensors. Air and ground sensors. These sensors are a fundamental addition to robotic farming that empower an ongoing understanding of the current state of farm, forest, and water conditions. Telematics hardware provide mechanical innovative devices. For example, tractors warn the mechanics that a break can occur soon. Animal biometrics, collars with GPS, RFID, and biometrics can provide continuous data on the various domestic animals. Crop sensors. Instead of endorsing the provision before application, the crop sensors supply a calculated amount to the application equipment. Optical sensors have the ability to distinguish the crops, for example, infrared light Infrastructure sensors can be utilized for checking vibrations and material conditions in structures, spans, production lines, branches and other foundation. Combined with a clever system, such sensors could sustain essential data back to support teams or robots. Genetically designed food, laboratory meat. This is the production of totally new strains of animals and plants, keeping in mind the end goal to better address natural and physiological needs. A takeoff from hereditarily adjusted nourishment. In vitro meat. Also known as refined meat or tube steak, it is a substance item that has never been a piece of a complete, living creature. Several current research examination tasks are developing in vitro meat tentatively, although no meat has yet been delivered for public utilization. Mechanization. Changing rate strip control. Based on existing geolocation innovations, future control of strips can save money on seeds, minerals, compost and herbicides by reducing input costs. Fast cycle with fast growth, the next era of specific reproduction where the decisive result is quantitatively examined and improvements are algorithmically proposed. Agricultural robots, also known as agribots, are used to robotize agricultural procedures, for example harvesting, picking, plowing, weed control, planting, water application, and so on. Accurate agribusiness, farming management based on observation and response to in-field varieties. With satellites and sensors, agriculturists can streamline the yields on inputs while protecting assets on a larger scale. Mechanical farming swarms, it is the use of a large number of small robots with sensors, which together will examine, anticipate, develop and concentrate crops from the environment with no human mediation. Small applications are not too far off now. Design. Closed natural ecosystems, these are ecosystems that are not dependent on the environment outside the ecosystem. Such closed environments turn waste products into oxygen, food and water, taking into account the ultimate goal of maintaining living structures that occupy the framework. Vertical cultivation, an increase in urban agribusiness and vertical farming develops plant or animal life in the urban environments. By using methods such as glass houses, vertical farms can increase normal light using productive lighting. The benefits are optimal use of space, continuous yields, protective climate, protection against diseases, pests and plagues and low transport costs.
Please like, share and subscribe to the channel for more future educational videos.